Welcome back. In today's video, we are going to talk more on power set. We did it in our first video, but in this video, we'll be solving 4 questions on it and we'll be going deep into power set. But before I start, I want you to subscribe to our YouTube channel, like this video, and give us your comment. Tell us how you think about this video. Your comment is very, very important. Now, what did we say power set is? We said if there is a set A, let's say we have 3 elements in that set, that the power set of A is actually another set that has the combination of all these numbers as its subset. What do I mean? That is, since this set A has 3 elements, we can actually combine 2 or 3 elements, combine them in different ways to form a new set. Now, this new set we are forming is what we call the power set. Now, we can combine only 1 as a new set. We can have only 2 as a new set. We can have only 3 as a new set. We can have 1 and 2 as a new set, as a subset. We can have 2 and 3 as a subset. We can have 1 and 3 as a subset. We can have our empty set as a subset. So the set that has all these subsets as, we can also have everything again repeated 1, 2, 3 as a subset. Now the set that has all these elements inside as a subset is what we call the power set of A. So that means we are actually combining all these numbers or all these elements here to form a bigger set. This set that we are forming is what we call the power set of A. Now, there's a formula we use to get the number of elements in the power set of A. This formula is a function of the number of elements in A. What do I mean? If you count, we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 elements in the power set of A. And we have 3 elements here. We have 8 here and we have 3 here now. To get the number of elements in the power set of A, that means the cardinality of the power set of A, it is 2 raised to power the cardinality of A. That is to say, it is 2 raised to power 3. That is how we get the cardinality of the power set of a certain set A. Let's try it again. If we have 2, 1 as a set B, definitely our power set B becomes the set that has only 1, the set that has only 2, only 1, the set that has 5, and the set that has everything. So these are 4 elements. This one has 2 elements. 2 raised to power 2 will give you 4. So this confirms our formula. So we'll be using that knowledge to solve this problem. Now, what if you are asked, in this power set, how many subsets have only 2 elements? If you are asked, for example, how many subsets have only 2 elements? You have 1, 2, 3. 3 subsets have only 2 elements. So that's a possible question. You can also be asked, how many subsets have only 1 element? This one has 1 element. This one has 1 element. This one has 1 element. So there are 3 subsets here that have 1 element. You can be asked, how many subsets have only 3 elements? These are the 3 subsets. 1, 2. These are the only subset. This is 1. So there's a way you do that. So suppose that A has 5 elements or 6 elements. It is very difficult for you to list out all those elements. So when you are now asked how many subsets has 2 elements or 3 elements, there's a formula you just use to get it straight, other than listing those elements out. Now this is the formula. Now you are working with the cardinality of A, then combination N. So when you are asked how many subsets are in the power set of A that has, let me use another alphabet, X elements, this is the formula you use. So for example, if you are asked how many subsets in this power set of A has 2 elements, the cardinality of this is 3. So we are going to have 3 combinations. Since we are looking for those that has 2 elements, we'll put 2 here. 3 combination 2 is 3 factorial all over 3 minus 2 factorial times 2 factorial. Remember this from your permutation and combination. Now our 3 factorial is 3 times 2 times 1. While 3 minus 1 is 1, so we have 1 factorial times 2 factorial. Our 2 factorial is 2, so this 2 cancels out, 1 goes, so we have 3. So this proves that the number of subsets in this power set that has 2 elements is 3. Let's count them. This one has 2 elements, 1. This one has 2 elements, 2. And this one has 2 elements, 3. So this proves our formula to be very correct. Now let's solve these 4 questions. Let's solve these 4 questions quickly. The first question says, how many sets, so it's subsets actually, how many subsets with 2 elements can be formed from the sets A equals 1, 2, 3? That's very straightforward. Because the cardinality of A is 3, there are 3 elements, we say 3 combination 2. Since we are working with the 2 elements, they said how many subsets with 2 elements. So we are working with 3 combination 2. So this is 3 factorial all over 3 minus 2 factorial times 2 factorial. So this is 3 times 2 times 1 all over 1 times 2 factorial. This one cancels. We have 3. So this means that there are 3 subsets with only 2 elements. Let's list those 3 subsets. We have 1 and 2, we have 1 and 3, and we have 2 and 3. These are the 3 subsets you can form from this, that we have only 2 elements. Now let's solve question 2. Question 2, we have how many sets with at least, they said at least 2 elements can be formed from this. Now when you hear at least, it means the lowest is this. So they said at least 2 elements, meaning that it can be more than 2 elements. We can have 3 elements, we can have 4 elements, we can have up to 5 because there are 5 elements here. So for the number of sets that can be formed for 2 elements, we have for 2 elements, we have how many elements are here? 1, 2, 3, 4, 5. We have 5 combination 2. So this is 5 factorial all over 5 minus 2 is 3, 3 factorial times 2 factorial. So this is 5 times 4 times 3 factorial all over 3 factorial times 2. This 3 factorial cancels out. 2 cancels out with 2 here. So we are left with 5 times 2, which is 10. So we have gotten the number of sets with only 2 elements that can be formed from this. But that's not what the question said. It said at least 2. Meaning it can be more than 2, it can be 3, it can be 4, and it can be 5. So let's look for 3 elements. For 3 elements, we have 5 combination 3. So this is 5 factorial. All over 5 minus 3 is 2 factorial, then 3 factorial. This is the same thing as this, so we also have 10. It also means that there are 10 subsets here that we have only 3 elements. So that's not all. We are going to look for the number of subsets that we have 4 elements. So for 4 elements, we are going to have 5 combination 4. This is 5 factorial all over 5 minus 1. 5 minus 4 is 1 factorial, then 4 factorial. This is 5 times 4 factorial all over 1 times 4 factorial. This 4 factorial cancels out. We are left with 5. So it means that there are 5 subsets with only 4 elements that can be formed from this one. Now lastly, we are now going to look for 5 elements. For 5 elements, we have 5 combination 5. So this is 5 factorial. All over 5 minus 5 is 0 factorial, then 5 factorial. This one cancels out. 0 factorial is 1. So we have 1. It means that there is only one subset with 5 elements that can be formed from this. Now let's go back to the question. They said how many sets with at least 2? At least 2 means it can be more than 2. So we have with 2 elements we have 10. With 3 elements we have 10. With 4 elements we have 5. With 5 elements we have 1. So your final answer becomes 10 plus 10 plus 5 plus 1, which is 26. So there are 26 subsets that can be formed from this set, which we have at least 2 elements. But altogether, how many subsets can be formed from this? That means the power set is just 2 raised to power 5, which is 32. So there are still about 6 more elements, subsets to go. So that's for question 2. Then question 3, we have how many sets with at most. They said at most, that means the highest you can go is 3 elements. It can be less. So now let's solve that. How many sets with at most means that's the highest you can go, 3 elements. Meaning that you can have 3 elements. You can have those that have 2 elements. And you can have those subsets that have 1 element. And those subsets that have 0 elements, which is just our 5. So for 3 elements, which is the highest, for 3 elements, we have how many elements are here? We have 4. So we are going to have 4 combination 3, which is 4 factorial all over 4 minus 3, which is 1 factorial times 3 factorial. This is 4 times 3 factorial all over 3 factorial. 1 times anything is the same. So this 3 factorial cancels out. We are left with 4. That's not the final answer. We have to, since they said at most, so we have to go below, since the highest is 3 elements. Now let's check for 2 elements. So for 2 elements, we have 4 combination 2, since 4 is the number of elements in A. So we are going to have 4 factorial all over 4 minus 2, which is 2 factorial, then 2 factorial. This is 4 times 3 times 2 factorial all over 2 times 2 factorial. This one cancels out. 4 divided by 2 is 2. 2 times 3 is 6, so we have 6. So this implies that there are 4 subsets that can be formed from this. And these 4 subsets, we have 3 elements. And this also says that there are 6 subsets that can be formed from this. And these subsets, we have 2 elements. Now, what about for those that will have 1 element? For one element, we have 4 combination 1. So this is 4 factorial all over 4 minus 1, which is 3 factorial times 1 factorial. This is the same thing as 4 times 3 factorial all over 3 factorial. This goes out. We have 4. So this implies that there are 4 subsets that can be formed from this set A that we have only 1 element. Those 4 subsets are A, that's 1, B, 2, 1, 3, and 2, the 4th subset. Now, what about those that will have 0 elements? It's actually just 5, but for righteousness' sake, let's still solve it. For 0 elements, we're going to have 4 combination 0. So we have 4 factorial all over 4 minus 4 is 4 factorial, then 0 factorial. This one goes out. 0 factorial is 1. So this is what we said, is only 5, so it's just 1. So our final answer becomes 4 plus 6 plus 4 plus 1. This is 10, so we have 15. So it means that there are 15 elements, 15 subsets that can be formed from this that will have at most 3 elements. We can as well try that. Let's check for those that will have only 2 elements or only 3 elements. A, B, 1. We have A, B, 2. We have A, 1, 2. And we have B, 1, 2. These are 1, 2, 3, 4. This corresponds to what we have here. Then we have 6 for those that can be formed with 2. We have AB, we have A1, we have A2, we have B1, we have B2, and we have 1, 2. So let's count. We're going to have 1, 2, 3, 4, 5, 6. So we have 1, 2, 3, 4, 5, 6, which is very correct. That's what we had here. Then for those that will have 1 element, as easy as ABC, we have A only, we have B only, we have C only, and we have, okay, there's no C, we have 1 only, and we have 2 only. Then those that have 0 elements, just our empty set, 5. So when you count this, you're going to have 15. So that's all for question 3. Then now let's move to question 4. Question 4 is actually a bit tricky, but it's quite easy. Now we are not going to be looking for those elements. We are looking for the cardinality of that set. Now the set, considering the power set of set A, that means set A has a certain number of elements. If there are 6 subsets with only 2 elements, in the power set of A, what is the cardinality of A? Remember that anytime we are solving for those subsets that have so number of elements, we always use the cardinality of that set, then combination, the number of subsets that we are looking for. So we are working with only 2 elements. So we have this equals to 6. So this means that there are 6 subsets that can be formed. These 6 subsets, we have only 2 elements. But we are actually looking for how many elements are in this set A. So n combination 2 is actually what we are looking for, 6. So let me call it n. So I have n combination 2. I don't want to be writing too much alphabet. Remember, n combination 2 is same as n factorial all over n minus 2 factorial. Then we have 2 factorial equals to 6. So let me break this one down. Our n factorial is same as n times n minus 1 times n minus 2 factorial all over n minus 2 factorial times 2 factorial is 2 equals 6. So this n minus 2 factorial can actually cancel out. We are left with n bracket n minus 1 all over 2 equals 6. So when I cross multiply, I'm going to have n bracket n minus 1. So this one goes to this side. I have over 1 here. 1 comes here. And this one comes to this side. So we are having 12 here. So if I open this bracket, I'm going to have n squared minus n. Then when I take this 12 to this side, I will have minus 12 equals 0. Now this is just a quadratic equation. So we can use the quadratic formula, which says that when x is in this form, ax squared plus bx plus c equals 0, that our x is minus b plus or minus square root of b squared minus 4ac all over 2a. This is our quadratic formula. So we use our quadratic formula to solve for n. So our n becomes minus b. The b is actually the coefficient of n. So minus times minus 1 is plus 1. Then we have plus or minus square root of b squared. b is minus 1. So minus 1 squared is 1. Then minus 4ac. This is 4 times a. Our a is 1. 4 times 1. Then times c, which is 12. Minus 12. 4 times minus 12 is minus 48. Minus times minus becomes plus. So we have plus 48 all over 2a. 2 times 1. So we have 2. So our n becomes 1 plus or minus. 1 plus 48 is 49. And the square root of 49 is 7. So we have 1 plus or minus 7 all over 2. Now this is where we now separate it. Our n becomes 1 plus 7 over 2 or 1 minus 7 over 2. 1 plus 7 is 8. So we have 8 over 2, which is 4. 1 minus 7 is minus 6. Minus 6 over 2 is minus 3. But we won't be taking these negative parts because we are working with the number of elements in the set. The number of elements in this set cannot be negative. So our n becomes 4. It means that the cardinality of the set A is 4. So that will be all for this video. Please do not forget to like and subscribe to our YouTube channel. Thanks for watching.